Topic, exponential functions. Focus it in a little bit. Yeah. Okay, so exponential functions, we could just say they're in the form f of x equals a to the x. It's just going to be like some number to a power, a number to a power. Like it could be 2 to the x power, or 4 to the x power, or 1/2 to the x power. And we want to start touching on what logarithmic functions are also, because we're going to talk about those next time. They kind of go hand in hand. They're inverses of each other. So we also have logarithmic functions. So I'll write those. I'll write g of x just so it's something a little different than the f of x. G of x or f of x, it's just different naming, how you could name the functions. It's still like y equals. Okay, so this one, and I just you can put any letter here you want. Like some books say b to the x. This one said a. Your text said a to the x power. So now a logarithmic function, it's in this format, log base a of x. Okay, so these two functions are inverses of each other. These two functions, these two types, this one's exponential and this one's logarithmic, they're inverses of each other. So if we went over to graph them, they kind of have a special relationship. Like I said, they're inverses of each other. So I'll draw, in red, I'll draw the exponential function. An exponential function kind of looks like this. There, kind of like that. There we go. There's what an exponential function looks like. And then a logarithmic function, since it's an inverse of that, it's a reflection of that over this dotted line I'm making right here. This is the line y equals x, just a line with a slope of 1, just an easy linear equation, y equals x. But the logarithmic function is a reflection over this dotted line I just made. And so a logarithmic function, if we graph it, it looks similar to that one, but it's kind of flipped down here. Just have to try to draw it carefully, kind of like that. There. So this one in red, that's your exponential function. And the one here in black, that's the log function. Logarithmic. I just say log. A lot of times, like, logarithmic, it's such a long word, so we just say log. Log and exponential functions. Okay, now we could also talk about what might come up in this section is also domain and range of these. What's the domain of an exponential function? What's the range? Same with logarithmic. What's the domain and range of those? So an exponential function, the domain describes what x values your graph hits. The domain of an exponential is just all real numbers. Another way to write that, all real numbers, is you could say the graph, it hits every x value. You can plug in any x number you want into this exponent. It hits all real numbers. So another way to say that, you can say it goes from negative infinity to infinity. Zoom in a little bit. Yeah, so domain is all real numbers. You can say it by saying the graph goes from negative infinity to infinity. It means you can plug in any number for x into that function and you can get an answer. And the range of this exponential function that we have graphed right here, you notice it didn't go below the x-axis. It didn't graph the red exponential graph. It's not going down here in this negative area for y. So the range is y is greater than 0. the range is y is greater than 0. And again, if you want to write it, this is like an inequality, a greater than or less than, they call that an inequality. You could also write it a different way. You can say that the graph, like I was saying, it's going greater than 0. So it goes from 0 and then it goes up forever. So you can say it goes from 0 to infinity. That's another way to say it. Like this, 0 to infinity. Okay, now the logarithmic function that's graphed right below it, what's the domain and range of that? Okay, well, the domain of that, you have to look at your x-axis and your y-axis. Domain is x. You might notice that this logarithmic function, it's graphing like it hits 1, it's going over here to the right, positive. The logarithmic function, it never goes over here where x is negative. It's never graphing over here. See, it just kind of turned and went down and goes right along this line, which is 0. So the domain for your logarithmic function is x is greater than 0. Notice it's kind of opposite of the range of the other one. See? So its domain is greater than 0. So it goes from 0 to infinity, you can say. And then your range of your logarithmic function is all real numbers. And again, you can say that goes from negative infinity to infinity. It's another way to say it. Or write the words all real numbers, or write it this way. Either way is fine. See, now, I wanted to point these out because the domain and the range of this one, notice what they are, and now the logarithmic function, it's like switched. See, like the domain is the x greater than 0 and the range is all real numbers, whereas up here the exponential, the domain was all real numbers and the range was greater than 0. So they're kind of opposites. Yeah, they're inverses of each other. And we're going to focus mostly on the exponential ones today, but we'll get to the logarithmic ones next time. Okay, now you're going to be asked to graph some of these exponential functions. You're going to be asked to make some tables on your assignment, plug in some values. So let me show you that quick. I'll move that paper and show you a different one. So they're going to be asking you to make a table and graph some things, some of these exponential functions. All right, so make a table and graph, which I don't think will be too hard on the WebAssign. It's kind of set up nice where they give you a little table to fill in. So I'll give you an equation. F of x equals 4 to the x power. Make a table and graph it. Okay, well, like I was saying, on the WebAssign, it's going to be kind of nice. It's going to be kind of set up for you. They'll have a table drawn out, and they'll put some values in here like 0, 1, 2, negative 1, negative 2, there. They'll have it set up like this, a table, and they have it written kind of sideways, I noticed, on the WebAssign. So it's fill in the table, figure out what goes in the bottom for the y values. So this should be pretty simple. You're going to plug in the numbers into your function. You're going to plug in values and use a calculator and figure it out. Figure out your answers. So if I do 4 and plug in a number like negative 2, you can grab a calculator and you could do that. Should be pretty simple. The power key is over on the side, like an up arrow, 4 to the negative second power. You might need to use parentheses when you plug these in your calculator. You might have to use parentheses around. Here, I'll zoom that in so you can kind of see it. See, like 4 to the negative second, type it like that. And then enter. So I got 0.0625 for this one. And actually, I want to show you negative exponents. It's actually the same as 1 over 4 squared. When you have a negative exponent, it actually puts it in the bottom of a fraction in the denominator. So it's actually the same as 1 over 4 squared. And 4 squared is 16. So it's actually the same as 1/16. And 1/16, if you divide 1 divided by 16 on a calculator, you get the same answer, the 0.0625. So you can type, when you type on WebAssign, you can type a fraction here when you fill in your charts, or you can type the decimal. I believe it accepts either answer. Yeah, it's 1/16. You can type the fraction and fill in your table on your assignment, or you can type the decimal. It doesn't matter. The WebAssign takes either one. And then the next one is 4 to the negative first power. We'll plug in another number. That should give you 1/4. Or type it on your calculator. 4 to the negative first, which is the same as 0.25. That one's the same as 0.25. So either way, like I'm saying, you can type in fractions or decimals on your assignment. Fractions are more exact. Sometimes decimals, you have to round them off. So if you get a decimal on your calculator and you want to change it to a fraction, you can do that too. Like you typed in 4 to the negative second on our first one, and we got 0.0625. You can change that to a fraction. You have to hit, depends on what calculator you have, but a lot of calculators have these fraction keys, these ABC keys. And you hit second ABC, or actually, wait, let me type it again. 4 to the negative second. Second, it's above the ABC key. I saw it. Second, and then it's the one, like on mine, it's right above the ABC. It has FD. It changes fractions to decimals, or decimals to fractions, and I get the 1/16. So it's just like proving to you it's the same thing. 1/16 is 0.0625. Okay, and on your assignment, you'll keep going. You're filling your chart, like 4 to the 0 power, that's 1. 4 to the first power, that's 4. 4 to the second power, that'd be 16. And so you'd fill in your chart, and then it's going to ask you to graph it. And since it is on a computer on WebAssign, I believe it gives you multiple choice, and you'll just pick out which graph matches with these values. So I could easily graph this. I can graph 0, 1, like go up 1. I started with that one because I looked at it. It's easy to graph. 1, 4. I can graph that. 1, 4. 2/16, that just tells me it's going to keep going up really high. So I'm not even, I'm not going to worry about making 16 dashes, but it's going to keep going up. -1, I get 1/4. -2, I get 1/16. So see, it curves and it goes right along the x-axis. Just like our notes showed, the exponential graphs are going to look like that. So part of the assignment is, making tables and graphing. Now, another part of the assignment is going to be recognizing when the graphs have made some transformations. Like when the graph is moved left or right or up or down. So we should study this a little bit, kind of look this over. I'm sure you've seen some of these before. You're just like our bell ringer today. That's why I gave you that quizzes bell ringer. You could see, like, when they add some numbers into an equation, it could move it left or right, or up or down. So there's some examples over here. I think it's easiest to look at the examples and what they do. So if you started off with a function, like f of x equals 4 to the x. If you started off with something like this, just like we were graphing, but then if they add a number into it, instead of just 4 to the x, what if it says 4 to the x minus 3 power? If that happens, if they add a number up in the exponent, minus 3, that moves the graph 3 to the right. If it was 4 to the x plus 2 power, that moves the graph 2 to the left. So when they change the power, when they add a number in with that little power, with that exponent up here, if they add a number in there, it moves it left and right. Okay, so see, you're looking at this, how this changed from the original. Make sure if you're not sure what we're talking about, just ask questions in the chat, and Mr. B will kind of tell me what I need to clarify. And if the number they add or subtract is not in the exponent but is at the very end, then that shifts the graph up or down. Then the graph could be moved up or down. So like if you have 4 to the x power And then see the plus 5 is like a big number at the end. It's not up in the exponent. It's just a number way at the end. That moves the graph 5 units up. And a -1 at the end, for example, would move it 1 unit down. So they're going to be adding numbers into the equations in different places, and you have to identify what happened. Which way did the graph move? And here's one. These are called reflections. I can move it over a second. Now we're going to look at some reflections where the graph flips. If the graph flips over the x or the y axis. Okay, so if the graph flips, then, okay, so here's the difference. It's where they put the negative. If they put a negative up in the exponent with the x, right in front of the x, up in the exponent, then the graph flips over the y-axis. But if they put the negative in front of the entire problem, in front of the 4, in front of the base number, then the graph would flip over the x-axis. So we could kind of look at what that means, you know, what does that mean? Or like what would that look like? So just a minute ago we graphed, here let me zoom this back out a little. Just a minute ago we graphed the 4 to the x power. So like we're saying, if they would have put, I'll use a different color, if it would have been a different graph, not 4 to the x, but if it would have been -4 to the x. So the little note sheet here says that's going to flip the graph over the x-axis. So that's a reflection over the x-axis. So your book might be telling you then to pick out a graph that does that. So here was our original like just 4 to the x, but now it says -4 to the x. So it's going to reflect over the x-axis. I'll put my pen here. This is the x-axis, right? So this graph that we made already in black, it would flip over that line, over my pen. So it would be like down here and going like this. I just sketched it really quick, but see, it would like hit, instead of hitting up here at +1, it would hit down here at -1 and keep going that way. So that reflection over the x-axis like flips it down. And you, or like, again, they had different things on the notes, or if it would have been 4 to the -x. If they would put the negative up, if they put the negative up in the exponent, then that would be a reflection over the y-axis. So you got to know about these different reflections and what they do. Reflection over the y-axis. And I could draw that in the green. I'll just use this green highlighter. Reflection over the y-axis, well, that would flip it like this. See, so it can do different things. So hopefully that helps you to see all these different things that can happen. The graph can move left, right, up, down, reflect different ways. Okay? And then I'll show you one, we're just almost done here with our notes. Graphs can also have horizontal stretches and shrinks, or vertical stretches and shrinks. Okay, so I'll zoom that in. Graphs can have horizontal stretches or shrinks, or vertical stretches or shrinks. So again, the notes here, I like this little note page because it just kind of gives an example of each one. If they put a number up in the exponent in front of the variable x, 4 to the 2x power, then they call that a horizontal shrink. Shrink by a half, but this one, there's difference between horizontal and vertical. So this one's called a horizontal shrink. Shrink by a half horizontally, or stretch, or this one has 4 to the x divided by 2. They call that a horizontal stretch. See, stretch or shrink horizontally. And finally, the ones where they put a number in front, Those are vertical stretches and shrinks. Vertical stretch or vertical shrink. Now with these, to kind of show you, I don't know, I kind of like playing around with showing them on Desmos or horizontal shrink. If you guys have heard of Desmos.com, I like that website, Desmos.com, because it can you can kind of play around with these and just be like, oh, this is what happens when I change that number, and you can kind of discover. What do you think? Oh wait, let me see something. It looks like it says people are waiting in the lobby. I got somebody waiting in the lobby. I gotta check here. Return to main menu to see who's waiting. Somebody, he might have got booted out. There, got him back in. Okay. But yeah, if you have ever heard of the website Desmos.com, you can kind of play around. Now, Mr. B, if I close out, if I can show him that, couldn't I, Desmos, off of here? We're just playing with the technology. So do I have to close out of that, you think?
Yep. So go up to that screen.
Okay, go back up to that screen.
Yep.
Maybe.
And hit the stop sharing. Okay. Yep. And now, yeah, you probably want to share Windows tab, right? Or Google tab. So hit it again.
Oh yeah, hit that so I can go to Google and pick it down here. Just pick like.
Oh, you don't have Chrome open, do you? Do you have Chrome open? You can hit desktop. That'd be fine. Or
let's see
window
here.
Or I would probably hit desktop. Well, this is this screen, and this window is this screen.
I want this screen, right? So
Okay.
which one should I do? Screen 2?
Okay. This is the screen that it's at.
Do I not like that? Or I can go up here then?
Yep. And now you can transfer this window to.
This is so weird.
Here.
I'm not used to this. Okay, wait. So here I want to go to Desmos.com.
Okay. Yep. We need to drag this window. So.
Drag it over there.
There you go.
Okay. Let's see.
Yep. And now they should see it. Yep.
So see if you can see on the computer. Yeah, it's kind of it's actually awesome that I have a student teacher right now, because getting used to all this technology too, he can help me out. But yeah, can you see it? Yep. Desmos.com. So I just went to this website, Desmos.com, just so, and you guys can play around with this too if you've never used it this year. Desmos.com is like a really cool graphing calculator. It's really easy to use. So like I was saying, we're learning about all these exponential functions. So you can just type an equation in there. Like we just looked at the graph 4 to the x power. See, and it graphs it for you. So like I was saying, now today, your assignment's going to be tell what happened when you add these numbers into this equation. So if I add 4 to the, here I'll do a new equation, y equals 4 to the, and then I'll, in parentheses, I'll type like x minus 5. What happens if I type a number in the exponent? See that? If I type a number in the exponent, x minus 5, do you see how the blue graph shifted? It made it move 5 to the right. And then if I type in x plus something in there, like plus 4, see how that moves the graph to the left? So you can totally just play around with this and see what happens when you type different things. What if I put a negative in front of here? Ooh, look, it flipped it. See, we talked about if you put a negative, it'll flip it over the y-axis. So see how I'm typing? You know, Mr. B's saying you can see my screen, which is a good thing. See, if I type a negative in there, it just totally flipped the blue line, the blue graph over a y-axis reflection. Or what if I put a negative in front of the whole thing? See, flips it down. So yeah, I'm trying to just show you with technology a little bit too, show you what would happen if you add these different numbers in. So the last part was the horizontal stretches and shifts and the vertical stretches and shrinks. Those do seem to be a little confusing to people. So it might benefit you to play around with this a little bit, like it shows if you did 4 to a power and typed in like 2x. It says it's supposed to be a shrink. A horizontal shrink. It says it shrinks towards the y-axis. So it kind of squished it in from side to side, made it get closer to the y-axis. See how the green line's closer to the y-axis than the red line is? That's why it's called a horizontal shrink. It says it shrinks it toward the y-axis. But if I put a fraction up here, I'll change it. If it says, instead of just x, what if it says like x divided by something? If I put x divided by 5, look at that. That one is called a horizontal stretch. It stretches the graph away from the y-axis. The y-axis is this middle line up and down. See how the green line got stretched away from the y-axis? So you can just play around with what happens when you add numbers into these problems. The vertical stretches and shrinks is when they put, here I'll get rid of that, I'll just type for the x like normal. So a vertical stretch or shrink, the vertical ones say they stretch away or toward the x-axis. The vertical stretch is when they put a number in front of here, like I'll put a 5. Okay, this one is called a vertical stretch. It says it stretches the graph away from the x-axis. So it kind of, the x-axis is side to side. It kind of pulled, see the green like pulled up away from this x-axis. See how it's like farther away than the red line's closer right here to the x-axis than the green line is? Yeah, that's just, you just have to kind of interpret it. It says vertical stretch. It stretches away from the x-axis. Makes it like taller vertically. You might also notice like where this graph, the red graph, hits here at 1, but the green graph, since it was stretched away, it hit farther away at 5 because we put that 5 in front. It has a different y-intercept, height of 0, 5. So hopefully you get a good idea of all these, different changes that happen. So let me go back to, I know it's like kind of interesting sharing these screens and everything. I'll figure it out. Let me see if I can do it. Okay, so if I go here and get rid of that. Now you can see, now you should be back to me. Back to me. Yep. All right, so I hope it kind of makes sense that showing you all these different transformations, when you do your assignment, it asks you to try to identify those different transformations. So let me go back to that sphere thing one more time. Ooh, I think it got messed up. Maybe. I wanted to go back to sphere maybe one more time, but okay. I'll post this online too. I'm gonna take a picture of those notes I was showing you, so it's okay.
Oh, we can scroll down.
Oh, it's probably there, but it got
right there.
Got moved.
Yep.
Okay, so these notes that I was showing you, I'm going to scan those and put this document on your Canvas module page for today too. So you'll have a list of all these transformations. So now is probably about time to start working on your assignment. Some of you might have already opened it. It's a web assignment, and it's over these exponential functions. And like I said, use some tools like Desmos.com is a good tool if you're confused. You can use it to be like, oh, what did that graph do again? I forgot. I don't know what happens. You can type the equations into Desmos.com if you're really messed up or confused. Hopefully you can do some of them without looking at Desmos.com. You can just look at the problem and be like, oh yeah, I know that one goes 2 units up. But, like you should be able to kind of tell like, oh yeah, that graph is up 5. But if you do start getting confused, Desmos.com is a good tool to use. So the assignment's on Canvas on February 18th in the module. Right at the bottom it says assignment. And it's called Graphing Exponential Functions. You click on it, it should take you over into this web assign, and you just work on your assignment there. And I'll just stay, I'll stay here. I'll stay logged in. So if you have questions, you can type in the chat. A few of you had sent me emails last week when you worked on your assignment. That was awesome. So If however you want to do it, if you need to email me questions or ask in the chat. And so you guys can start working on your assignment. Anything else I need to add, Mr. B? You think that's pretty good? Okay, so you guys can start working on your assignment and let us know if you have questions like in the chat or email me, whatever works for you. Yep, that's what we're here for. We're here to help you out. So